Hey, Facebook, welcome tonight to our Facebook Live where we're going to talk about division that doesn't make your students cry, right? Because we know division, it's tough, right? It's one of the hardest things we do. Third, fourth, fifth grade, sixth grade, seventh grade division, long division is crazy and it's crazy hard for kids. And there's those steps and we have all these things we can memorize. Or could we do a better job of actually helping kids use what they know with a whole lot less stress and pressure and memory tension so that they can just solve division problems using what they know? If you were able to watch our last Facebook Live, we talked about the ratio table as a tool to help kids multiply. But you know what? It is such a fantastic tool because it can also help kids divide. Hey, Robert, glad to have you on tonight. Thanks, tons. Hey, we've already got tons of people on. So let's talk about how we can de-escalate long division, how we can help kids use what they know, take the pressure out of them having to have memorized steps. Stop the non-mathematical rote memory of steps. And what could we do to really help give our kids more confidence in long division? Yes, Robert. However, honestly, I'm not going to get to synthetic division tonight. Polynomial division, maybe at the very end of tonight, but for sure in our upcoming webinar. So I'm going to tell you about a webinar where I'm going to go into more detail. Facebook Lives are really great for kind of a quick, wow, look how cool this is. And then I'm going to do a webinar a week from Friday and Saturday. So I guess I should give you dates on that, huh? January, I totally have them handy somewhere. Yes. January 22nd and January 23rd, I'm going to do a webinar where I will go into more detail and I will get to high school level application of how we can help kids do polynomial long division. But tonight, let's focus on division, sort of normal long division. What could that look like with kids thinking and reasoning and a whole lot less rote memory? So let's have a typical problem. Maybe I were to say something like, we're going to deal with a problem like, oh, give me a second, I got to change my input. And there we go. Nope, let's make it even bigger. Now you'll be able to see it. Okay, cool. What if I said to kids, we need to do something like 420 divided by 12? Well, my first thing I want to say tonight is when you begin teaching long division, whether they've had it before or not, but you are doing your first shot at long division with kids, put it in context. So don't give them that naked problem yet. Help them do some stuff in context first. And then, thanks, Kim, for putting the in the chat the times and the dates. Then, after they've had a story around it, then we're going to go into where we decontextualize it and just do it sort of more naked about that. If synthetic division makes you cry, teach French. No, I mean, I taught German and math. Just saying, when I was a high school math teacher. All right, so let's get down to it. Give a context like, let's say that we have 420 students and we're going on a field trip. Okay, maybe non-COVID time. 420 students, 420 people, 420, like make up your story. And we know that we can put 12 kids in a van. How many vans, how many vehicles are we going to need in order to get those 420 students to the thing if we can put 12 students, 12 kids in each van? So starting with that context, especially if I've already done some multiplication with kids in a ratio table, which I would highly recommend, do a little bit of multiplication first, or actually do quite a bit of multiplication first, then this falls really naturally because then kids can sort of think about, well, if I've got, let me think for a second, if I've got one van, then I know it can fit 12 students. But I don't want to just take 12 students somewhere. I need to get 420. So it's sort of like I'm going to kind of extend my ratio table and say, I need to get to, that's like my goal. And I'm curious how many vans that's going to be. So then kids use what they know. Now, the first thing I'm going to do is sort of a less sophisticated strategy. Sometimes we'll have kids say, well, okay, what if I took 2 vans? That'd be like 24 kids. So you double the vans, you double the number of kids you can take. Then kids might say, well, what about 3 vans? And kids start filling in some things they know, like what's a library of things that we could work with? So then they might add that 2 plus that 1 to get the 3, and then the 12 kids plus the 24 kids to get the 36 kids. Okay, cool. What else do we know? Well, hopefully they'll start to go, ooh, 36, 420. Like, I don't want to do that one at a time all the way up. Man, what else do I know? Ooh, we should have worked on the times 10 pattern for sure before we hit division. So we're going to work on that times 10 pattern. And we're going to say, so we're going to multiply here times 10, just like we multiplied that 1 times 10. And so that would be 120. Hey, well, that's closer, 120. What else might kids do? Sort of a less sophisticated strategy. They might double from here. And so they say to themselves, okay, well, if I double the 10, then that would be 20 vans. Okay, how many kids is that? Whoa, we're getting big now. Okay, that's 240. Well, it's not quite. Like, I want to help kids. This is a very important teacher move at this point. How many more do you need? Ooh, kind of a lot. So maybe we need to keep like dealing with bigger numbers. So one of the more very important questions, let's see, I'm going to put it right over here, is I'm going to say, how many more? Or how close are we? How close are we? This is a very important question that kids sometimes they just start putting in things they know, and they like figure out how far away you are. Oh, then that can kind of help them think about a next move. Sometimes kids at this point will double again. They'll say, oh, well, we need lots of them. So let's go 40 vans. When I double that, then I get to 480. Now we're at too many. Okay, too many vans. So let's see, what can we do? We got too many. Well, so we know now it's going to be between 20 and 40. Well, since we already have the 10 and the 20 there, let's go ahead and add that 10 and that 20 together. And when I do that, then I will get 30 vans. And let's see, that'll hold 120, 240. Now we're hopefully you've done some work with kids so that the addition is something that they've kind of got. If not, we'll do some more Facebook Lives where we'll talk more about addition and subtraction. But for now, we're just going to sort of assume that they can do that at 360. Okay, so not enough, right? They need to get up to 420. Well, again, let's ask that very important question. How many more? Like, what's left? Ooh, 360 to 420. That's just like 40 and 20. Is that just like 60 more? 60. Well, do we have something that could help us get to 60? Now, at this point, it kind of depends on what kids know. They might look at 120 and say, hey, 60 is half of 120. Okay, well, so if I need 60 and I can half that 120, then I'm going to half that 10 vans, divide that in 2. And so half 10, that's 5. So now they might also know that 5 times 12 is 60. That's a 60. That doesn't look very, let me make that 60, more of a 60. And they might know that just 5 times 12 is 60, but they might not. That's not a real common one that kids get when they're beginning division. But it might be, could use that, or they might see the relationship from 120 to 60. They also could have come over here and thought about the 24. In fact, maybe I'll clean things up just a little bit. They could think about this 24 and that 36. Those would get, in fact, not even close. If I add those together and add that, there's the 5 right there, right? So that's several different ways that they could sort of find that 60 students that we had left to get. And now that we have that 60 students, then let's see, we decided that 360 and 60, this is too messy. Let me clean things up a little bit. We decided that we were looking to get that 60 because we knew that that 360 plus 60 was going to give us that 420. So then we need that many vans. We need 30 plus 5 vans. How many is that? That's 35. All right. Now, some of you might be like, Pam, I thought you said this was going to be easier along division. Hey, hang on, everybody. Hang on. I didn't say it was easier. What I said is it doesn't make students cry. Let me tell you what, this is students using what they know. This is a beginning strategy. So then we would hope to encourage students to use more sophisticated strategies. So I'm going to clean that up just a little bit. We would hope kids would say something like, well, let's start with the number of vans and the number of students. And that's, let's see, 1 van fits 12 students. And I'm trying to get up to that 420. That's still my goal. Now we'd hope that kids kind of get there a little bit quicker. One way they might do that would be to say, let's see, 2 vans is 24. Pam, I thought you said quicker. Well, what if I go straight from that 2 to times 10? What if I scale that times 10? Now I'm at 20. Check it out. I just skipped a bunch of stuff. That's times 10. And now I'm already at 240. Now maybe all right, the 240, what can we do from there? Well, maybe I might think about 3 vans. That's 36. And you know what we start to see kids do? And then they go, ooh, so 30 is 360. Did you see me do that? So cool when we see kids will do that. They're like, okay, vans will get us 36 kids times 10. And they just sort of, now, not always. Sometimes they'll leave the 3 and then they'll scale it up kind of like I did the 2 to 20. But it's a really great move when all of a sudden they go, hey, I can get really close. How close am I? Ooh, I'm just 60 away. And then again, kids could use lots of different relationships, but they might be able to say, ooh, 12 to 60. Let's see, that's times 5. So that's 5 vans. And then I can just sort of add that 30 and that 5 together to get 35. So we would hope that kids would start to use bigger and bigger chunks of numbers, bigger and bigger bits that they can think about, the more sophisticated that they get. Even to the point where you might see a kid say, let's see, let's do one slightly more sophisticated. Yeah, we would hope to get kids to look at a strategy where they've got vans and they've got students. They know that one van holds 12 students. And they might say to themselves, let's see, I'm trying to get to that 420. What do I know about 12? What do I know about 12? Well, I know 3 times 12 is 36. Why did I do that? Well, because now I've got 30 times 12 is 360. Bam! How many do I have left? Well, we do that little subtraction. We'd find out we need 60 left. And so they would say to themselves, well, I need 60 more kids. How can I get from 12 to 60? There's the 5 and there's the 35. That's what it might look like for a kid who's had some practice, that we've done some specific work with them to get them more and more sophisticated, fewer and fewer chunks. And y'all, it's possible. And it's not only possible, but it is desirable, because really what you're seeing is a kid move from less sophisticated to more sophisticated to more sophisticated multiplicative reasoning. And we want to build that multiplicative reasoning. That's our goal. It is far more our goal to build kids' brains to think and reason multiplicatively in division than it is to just get answers to questions. It's not enough for us to just get answers to math questions. Really, we need to help kids build their brains to get more and more sophisticated, so that they're literally have more neural networks, so that then they can handle the math of the middle school. It's not enough for them to just do a mother, brother, bring down, subtract. See, I can't even remember does McDonald's sell cheeseburger? Like whatever the rhyme is that you've sort of got going on in your class to remember those steps. Instead, let's put kids' brain power into actually understanding what's happening in division. We're just sort of scaling up until we get the right number of students. In this case, we had the students, we need to know the number of vans. So a ratio table is a really important tool that we can help students use what they know about multiplying in a ratio table and use that to help them divide in a ratio table. Dun, dun, dun. There's a couple of other reasons that I'm going to encourage you to use ratio tables. Some of you might look at this and go, oh, I already do that. I do the Lucky 7. We're good to go. So this is a little bit different than the Lucky 7 in a couple of really important ways. Let's look at that. And you might not know what I mean by the Lucky 7, that some people call it that. Basically using partial quotients, where we just sort of tell students, so sometimes that might look like we write down the 12 and we write down the 420, and then sometimes students will like do this, and see, you said there's sort of a 7 there, and then they'll have kids kind of do what we did, where they'll say, well, 10 of them, that would be 2, and I don't want to show too much of this. But notice that in that sort of partial quotient, and then I would sort of add up the things that I use over here. If I do that, one thing I do is I kind of put kids in this place where the subtraction is right in front of their face, like this, as a subtraction algorithm. And now we get kids that are kind of back in, I'm just going to do the algorithm for subtraction. If you don't know me, if you're new to Pam Harris and math, then you don't know that I don't really want kids thinking about the algorithms with subtraction. I want them thinking and reasoning about subtraction. You'll notice that when I was thinking about I need to get from 360 up to 420, then I did a lot of thinking about, well, how do I get from 360? This is a number line, and that's 360, and this is 420. I don't know if you heard me say, well, that would be 40 to get up to the 400. And then I just need another 20 to get up to the 420. That difference is 60. If I got kids stuck in the subtraction algorithm, I'm not having kids think about that difference at all. And so then they're kind of back in a memory thing, a rote memory. How do I do the subtraction algorithm versus how can I be thinking about what's happening in the subtraction? And I want to keep kids there. So one reason that I'm not a big fan of the Lucky 7 is that it throws kids into sort of stupid subtraction. But another reason that I'm not thrilled with the Lucky 7, let me clean that up a little bit, is let me give you a slightly different problem to solve. And I want to talk about how doing it in a ratio table allows a really cool thing to happen. And doing it in a lucky 7 or a partial quotient method doesn't allow that to happen. So let me give you a problem. What if we were going to talk about, say, oh, by the way, I've just shown you 3 ratio tables that are horizontal, but not all ratio tables are horizontal. We can also have them vertical. So just so you can kind of get a look at that. What if we change context really quick? And what if we said that we have, let's say, a box of mints, and in that box of mints, we have 23 mints in that box. And then what if I said to you, hey, I want to know, what if I have 2,277 mints? How many boxes would we need? So that's a vertical kind of a look at a similar division problem, right? We're asking for 2,277 divided by 23. Could kids use what they know? Could they say to themselves, 23, whoa, 23, how am I going to get 23 all the way up to 2,277? How am I going to do that? And they're going to think. I'm going to let you think for that just a second. I'm going to read some quotes over here. Oh, good, Tammy. I'm glad you like the vocabulary. Excellent. Kim, what is Pam using to write on tonight? Hey, Sid, I always write in, I always present the same way. And we have actually put it on the website because so many people ask about it. So you can go to mathisfigureoutable.com/how. So mathisvariable.com is my website. You can see it down here on the bottom of the screen right there. I didn't circle that very well, did I? I can't actually see that on my thing. I have to look at the computer to see that. If you go to mathisfigureoutable.com/how, totally talk all about the way that I present. And those of you that are doing virtual synchronous kinds of stuff or videoing yourself, totally might be a thing that would be helpful for you to use. So I really like that setup there. Game changer. Yeah, Stacy, game changer with your 5th graders. I'm so loving the fact that you took the course and learned how to use ratio tables with your students. Well done. If you guys are new to the workshops that I offer, hit the webinar that I'm doing a week from Friday, week from Saturday, and we'll teach you some more about ratio tables. So the upcoming webinar, blah, 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 blah. I'm all over the place. The upcoming webinar will dive deeper into how to use ratio tables with multiplication, more about division, and also how to use ratio tables to solve proportional reasoning problems. Y'all, this is such an important model that we need to use more so that we can use it in all those places. All right, back to our mints. If I'm trying to get 23 up to, oh God, what is that number? What is 2,200 kind of close to? Is that kind of close to 2,300? Like, I wonder if we could sort of scale up. What would it take to get 23 up to 2,300? Is that like times 100? Now, we would want to do some work with kids to be able to get them to do that. Well, now that I've done that, now I ask that all-important question, that very important question we wrote up here. How many more, or how close are we? That all-important question. Well, how close are we? Let's take a look. Let me get rid of that a little bit. So how close is 2,300 to 2,200? Let's put that on a number line. If I'm at 2,277, those of you that have learned I have, you need, if I have 77, what do you need to make the next 100? Like, how close am I to 2,300? Well, let's see, 77, I could go up 3 to get to 2,280. Then I've got 20 left over. Is that just 23? Are they 23 apart? See how I'm thinking about that subtraction, thinking about how far apart they are? Well, wait a minute. If they're just 23 apart, check out what's going on over here. These are just 23 apart. So this just needs, I got 23 mints. I've just got a box. So if I subtract 23 mints over here, I subtract a box and bam, I'm at 99. Y'all, we just solved the problem. 2,277 divided by 23, and we got 99. Thinking and reasoning using what we know. Long division without kids crying, where they just use what they know. And one of the, now you might be like, Pam, I don't know if my kids can get that 23 up to 2,300. Well, that's why we would want to do some multiplication work with them first, so that they get used to times 10 and times 100, and that they can get closer, or they can get sort of nearer their goal. And the quicker they can get closer to their goal, the easier things are going to float for them. But remember, I brought this problem up for a reason. So one of the reasons that I brought this problem up is I wanted to sort of talk about how the using a ratio table to divide has one up on this sort of lucky 7 or partial quotient strategy over here. When I do this partial quotient strategy, I really can't do the over strategy, which is what we just did here. We were able to go a little bit too high, a little bit too much, and then just subtract off that little extra, subtract off just that one box of mints to get to those number of of mints and one more and we were able to use the over strategy. So everybody, the fact that we can use the over strategy is a huge reason that I want to be able to divide in a ratio table. All right, cool. Let me sort of look and see what we've got going on over here. Let's use a ratio table this way in a webinar. Yeah, I love Kyle, Pearson, John are great guys. We totally support each other. We're colleagues and really like the work that they do. Really, you have taken the subtraction division away from long division, and kids are now thinking multiplicatively and additively. Yeah, Robert, that's a way to say that. Sure, absolutely. I'll let you categorize it that way. This is like adding up to subtract, multiplying up to divide. Laura, well said. Exactly that. Yeah. So I'm using what I know to multiply up in order to divide. Now, it gets even cooler. I guess I could keep looking at comments and then I'll get even cooler. Can I get even cooler in just a second? So many errors in subtraction using partial quotients. Amen, Amy. Amen. This is where I'd use I have you need. Absolutely, Kristen. I love how you model your thinking and the questioning, wondering going on in your head. Oh, Jackie, that is so huge. Like that is probably the biggest thing that I learned early on in my dive into numeracy is how important it is for us to have sort of this out loud dialogue about what's going on in my head so the kids can tell me what's going on in their heads. And then all of a sudden it becomes a thing. Oh my gosh, do I have time for a story? I have time for a quick story. Okay, y'all, I'm in PT. I hurt my knee. I'm in physical therapy. I'm going to physical therapy. I just went today. So every once in a while, physical therapists will say something, I'm doing the exercises, right? Not with my arms really, because it's my knee. But anyway, I'm doing the exercises and the physical therapist said something mathy. And I was like, oh, and she's like, well, what do you do? And I'm like, oh, I teach math teachers. You teach math teachers? And we talk about it a little bit and some numbers came up. And so every once in a while, we'll just chat about numbers a little bit. Today, numbers came up and it was literally a division problem. And as we were doing this sort of division problem, it had everything to do with how many patients she usually sees in a day. And so on average, how many patients is that per hour, right? And as we were doing it, she goes, I've never spoken about how I think about math. And now, like, all we're doing is just chatting about how we're thinking about it. It's so interesting to hear how you're thinking about the math. I feel like I could have been good at math. I feel like maybe I am better at math than I ever thought I was. Woohoo! I mean, that's like the whole goal, right? The whole goal is to get kids not crying over long division, but feeling like they have power over long division. Like she even said, I'm just using what I know. Absolutely. All right. Let me do one more, like the coolest thing ever. So I don't only want to multiply up to divide. I definitely want to do that. And all the examples that we've just done, we definitely want to build that in kids. But check out what else I can do with ratios. So I'm going to do a slightly different ratio. The ratio that we've got here is sort of 1 van to 12 students, and then we sort of multiplied up in order to divide. Now I'm going to look at that ratio slightly differently. So it's still 420 students, still 12 kids in a van, but now I'm going to look at those 420 students, and I'm going to say I've got those 420 students, and I need to divide them out over those 12 vans, right? I sort of need to take those 420 students, and I need to like go in some vans, get them in their van so that they can go on the field trip. And then I should be able to figure out how many. So I've got 420 students. I've got 12. No, not 12 vans. Pamela, I did that just to see if you're paying attention. Okay, not really. I totally screwed that up, not on purpose. I've got 12 students per van. 12 students fit in a van. 12 students per van. What can I do with that? Well, if I'm thinking about a ratio table, I'm on a ratio table. What I want to do is think about the fact that if I've got 420 students and I've got 12 students in a van, is that similar for me thinking about what if I only had half as many students? So let's see, half as many students. That would be what, 210 students? Then what if the vans only held half the number of kids? Would that be the same? Is that an equivalent situation? Yeah, like I would still put those kids in those vans and it would still sort of be the same kind of situation going on. And then now that I've got 210 students and 6 students fit in a van, how many vans would I need? Let's see. Well, could I do something else? So I'm thinking about 210. I'm thinking about 6. I'm looking at the time, trying to decide if I want to do a less sophisticated than a more sophisticated. Let's go ahead and do that. So I might think about, I'm trying to factor 210. So that's sort of like 210 is kind of like 2 times 105. So then can I think about dividing both of them by 2 again? So if I divide them both by 2 again, then let's see, that would leave me with 105 divided by 3. So now I've got 105 students and I've got 3 students per van. Okay, so I sort of have an equivalent situation. Let's keep going until we can sort of figure out what that equivalent ratio would continue to be. 105 divided by 3. 105 divided by 3. What do I know? Let's see. Do I know? I kind of want to do this the other way. I'll do it this way first. 105 divided by 3, what do I know? Let's see. I think I'm going to model that this way. If I'm trying to do 105 divided by 3, can I think about that as 90 divided by 3? Because I know that. I know 90 divided by 3, that's 30. And then what am I left with? 90 to 105, is that 15 divided by 3? Oh, sweet. Well, 15 divided by 3, that's just 5. Hey, there's our 35. Check it out. Now, when I divide that by 3, and I divide that by 3, then I end up with 35 to 1. In other words, I've simplified the ratio of 210 to 6, or excuse me, 420 to 12, and I've simplified that ratio all the way until I get to 35 to 1. And all of a sudden, I've been able to sort of simplify a fraction, a ratio, into a ratio that kind of gives me the answer. Now I'm at 35 to 1, and woohoo, our answer is 35. So I wanted to kind of give you an example of a different look at being able to solve a division problem by kind of turning it into the ratio that it is, and then using a ratio table to simplify that ratio. You guys, this has huge implications for us being able to simplify other ratios and fractions. And I can use ratio tables to do that work as well. So now I can sort of choose what strategy do I want to use as I'm thinking about solving the problem. I can sort of multiply up, or I can kind of simplify the ratio. Both times I'm using a ratio table as a tool to help me think about solving that division problem. I mean, what do you think? Kind of amazing, right? All right, let's see what some comments are going on here. Lauren says, my students struggle with realizing that going down 23 minutes is down a box, not 23. Absolutely. Lauren, that's totally going to happen. And I think Kim's talking to you after that at some point. Typical in the beginning, the key is to stay in context. Absolutely. In fact, we really want you to stay in context big time. So let's go back up here where we got students and vans. Often, in fact, probably a better place to do it is over here with the box of, yeah, because you said the 23. You're even in the box of mints, where kids will say, oh, so if I subtract 1 over here, then I'm going to subtract 1 over here. Totally. And so then we'll say, wait. If you subtract a box, are you going to subtract 1 mint? How many mints are in that box? Lauren, let me tell you, over time, as we start to work with kids, I'm trying to think about where I could put an example like this. As we start to work with kids, we see that kids will absolutely make that mistake. And let's say that we're even in sort of a decontextualized problem, like a naked problem. We don't even have context. If we've done the vans and the kids, if we've done we like to spend time on a few really good contexts, like the box and mints. All I have to do is say to a kid, whoa. If I subtract a box, do I subtract a mint? Even though we don't even have boxes and mints in that particular problem, the kid goes, oh, that's right. Like we connect it back to an experience we've had. We give them more experience with that. Kids work on that. Kids need to work on that because that's one of the important parts of the problem. Staying in context, thinking about what's happening. We need kids to run into that sort of confusion and deal with it, not just do a bunch of long multiplication steps where then we get a bunch of kids who can do some steps. Maybe if they remember them right and they have the acronym, they can get answers, but they really can't reason through stuff because we never sort of put them in a position where they got a chance to run into that potential confusion. Let's see. I am going to take a drink. Julie, good question. So in Pam's perfect world, we're going to just have a couple minutes left. So let me address, Julie asks, so it looks like the standard algorithm is not really needed to understand division. So how do we handle the fact that the standards call for the standard algorithm in 6th grade? This is my suggestion. My suggestion is that in 3rd, 4th, 5th, and 6th grade, all the way up until the last little bit of 6th grade, you do thinking and reasoning and build your kids multiplicative reasoning and multiplication and division, and they are confidently solving problems and getting more and more. You're nudging them towards more and more sophisticated, bigger jumps in their problem solving. And then you say, hey, we've been looking at lots of, because you will have said, hey, how'd you do it? And some kid did more like our strategy up here. And then you had somebody else share, and somebody did a more sophisticated strategy. You had someone else share. We've been sharing strategies all the way along. Someone else might have tried solving it this way. And as we're comparing those strategies, kids get really used to comparing strategies. And so then at the very last possible minute that you can get away with it, like the last week of school, yeah, I'm kind of suggesting the last week of school, you hit your standard. And you should say to kids, hey guys, here's a way that your parents sort of learned to do it. So if we were to sort of look at they did stuff like this. They would ask themselves, let's see, 12 divides into 4. No, 12 divides into 42. Yeah, 3 times. And they would just write this 3 down. You guys, what could that mean? And then you ask the kids to like help you figure out what's kind of sort of happening. You don't teach the algorithm as a thing to do. You just put it up in front of kids and let them sort of parse it out. Like, why does it work? They parse it out a little bit, and then my goal is that they will have the response that my kids have. So I'm actually going to make me big for just a second. So my personal kids never learned the long division algorithm. I had dived into my kids' school district. We had changed things enough. My first one saw it a little bit. I had 4 kids. The 3 just never did long division. They just multiplied up, or they simplified ratios. And to this day, if I ever like show them the long division algorithm or something, they will say, I mean, that's really cool. Like, it's really complicated. There's all these steps, and the place value is really hidden, like the 3 instead of 30. And whoa, like why would I do that if I can just think about it? Like, why would I fill my brain with something I don't need? I'll just solve the problems thinking about it. That's my perfect goal. So you might follow that up. Oh, dividing decimals. If you want to see division of decimals, join us on the webinar. I don't have time tonight. Facebook Lives give us sort of this brief kind of glimpse at what's going on. We'll totally do division of decimals in the webinar on Friday and Saturday in a week. I know we put those dates in there. Hopefully you're looking at the comments to see when they are. I'll pull that up in a second. Totally works. Like we would want to do multiplication with decimals on a ratio table, and then division of decimals. Woohoo! No problem. Now I say no problem, but it's a fairly easy transition. Now I just start using decimals. We have to get kids thinking multiplicatively with decimals first, and then division with decimals just falls right out. And then we get really, I'm going to take a second to just show something really cool. Then we get this thing. Like, let's say instead, let's say our problem was 42 divided by 1.2, right? And so then typically we would do this garbage, and we would say this has to move over there. And so then I have to like move that, and all this, and kids don't know where they're moving, and all the decimals and crazy. What if instead of doing that, what if we said to them, hey, let's think about that like we have been on a ratio table. Let's think about that ratio, and then let's get an equivalent. Let's scale that up times 10. What if I scale both of those times 10? Now I'm at 420 divided by 12, and bam, now I can just do that problem like it is the why we move the decimal in long division with decimals. And all of a sudden kids like, well, yeah, I've turned it into a problem with whole numbers, and I'll deal with the whole numbers. Now they don't have to, but that is the why you move the decimal in the long division algorithm. Nobody ever understands that over here. They just do it, and then they screw it up, and all the decimals are everywhere, and nobody's getting the place value right. Or we really get kids thinking and reasoning using place value, and then we get a lot more understanding. All right, we're totally out of time. So it's about to be, yes, very intentional about context. Nicely said, Lauren. I see and love the math. How do you explain the 35-to-1 ratio in terms of the context? That gets a little harder, Laura. You kind of want to do all the contextual stuff with ratios that make a little bit more sense than the one I just did, and then be able to decontextualize to just say to yourself, in fact, I was totally supposed to mention this and I forgot. Thank you, Laura, for bringing it up. That we really want to get kids good at using the context to help them think about what's going on. And if it feels like I'm gonna do, then I'm drawing the ratio table this way. But if it feels more like a ratio that I can simplify, I'm gonna simplify the ratio this way. And then we help them make the transition. And this in a big way is the 5th and 6th grade teacher's job, is to help the kids go, this is a division problem. It feels like I should simplify the ratio, but that's a yucky ratio. Like, for example, if I was in the 2,277 divided by 9, divided by 23, that is a yucky. Oh, you can't see that. Hold on. Bigger. If I was doing this problem that's not a great strategy to simplify that ratio. It's much better to multiply up to solve that division problem. What we really want kids to be able to do, though, is choose. We want them to think about the problem and make sense of it, and then say to themselves, hey, I know that with division, I could choose to multiply up to solve this one, or I could choose to simplify the ratio. What am I going to do with these numbers? So that way kids get less stuck in the context says I must do this, and more flexible. And that hits the standard that says kids should be able to decontextualize and recontextualize. That's what it means. That's what that standard means, that I have strategies, I understand what's going on, and then I get to choose which strategy I use based on the numbers, kind of what they're begging for me to do. All right, cool. I am so going over time tonight, and I've got to get done. Let's see. Yes. Excuse me. This is amazing. Love listening to your podcast on Ratio Tables. Woohoo! Love for you to join us on the webinar coming up. Oh, Tammy's telling me can't see. Sorry about that I didn't bring that back on earlier. Thanks for telling me. When I simplify a fraction, I tend to divide the denominator and numerator by easy numbers until I can't. Yes, Robert. I'm not sure why you said yet, because yes. And we can't see what you're doing. Sorry. Now you can. My bad. Much better way than division algebra, which shows no understanding. Yeah, absolutely. Colette, yes. So, y'all, I did a couple of examples tonight. We just really skim the surface of how we can help our kids do long division without crying, without tears. We can really help them use what they know. If you'd like to know more, may I invite you to my webinar that I'm going to do Friday night and Saturday. And I know the dates were going in the comments, and I'm a dork and don't have it in front of me. Sorry about that. It's Central Time. I'm in Central Time, so it's 7 o'clock Friday night, a week from this Friday. And so the 20, help me, do I have my calendar in front of me? The 22nd, 7 o'clock on the 22nd, and 11 o'clock Central Time on the 23rd. Y'all, if you'll go, I just put across the bottom, mathisfigureoutable.com/webinar21 has all the details. Let's say you're a teacher, you're busy. If you're a teacher, that equates busy, right? I totally get that. If you're not sure what your schedules are going to be like, go ahead and register for the webinar, and then you'll get the link to the recording. And that way you can sort of watch it at your leisure. It'll be available for a while after we do the webinar. So I invite you to the webinar. What is the webinar about? It is all about ratio tables, where we'll look a little bit more in depth at multiplying with ratio tables. We'll look at dividing with ratio tables. We will look at solving proportions with ratio tables, and even some fraction stuff with ratio tables. So ratio tables, one of the coolest, in fact, we called the title of the webinar, The Ultimate Math Model That You've Been Waiting For. So we'd love to have you join us on that webinar. Sign up. Thanks tons for joining me tonight. I will look and see if we have any last. Oh, got a couple comments since I looked last. Oh, thanks. You guys are putting the dates in there. Thanks. I appreciate that. I'm so not good at that. Yeah, nice, Laura. Excellent. All right. Totally cool, everybody. Thanks so much for joining in tonight. All the best with division with your students. Take care.